Okay, so in the last video, I talked about the unbiasedness of OLS estimates in the presence of some assumptions. In this video, I'm going to talk about two issues. The first one is what happens with the OLS estimates if you estimate a model like this by including this variable x3 in the model, and this x3 variable has no partial effect on y when x1 and x2 are controlled for. And this type of model is called overspecification. That is, we are overspecifying the model by including an irrelevant variable in the model. So although x3 has no effect on y, holding x1 and x3 constant. So this type of overspecified model, that is including one or more irrelevant variable in the multiple linear regression model, does not affect the unbiasedness of our beta coefficient. Is it okay to include as many variables as you want, even if those variables do not belong to the model? The answer is no. The reason is, although the estimates that we get from OLS, those are unbiased, the variance is not. I will define the impact of variance on these beta coefficients in the next chapter when we'll talk about the inferences from OLS estimates. But here, although including an irrelevant variable in the model, it does not affect the estimates, it may have some impact on the variance. Alright, so that's the first problem. The first is including an irrelevant variable in the model. And we saw that it doesn't have any effect on the unbiasedness of these beta coefficients, although it may affect the variance of those estimates. Okay, so the next issue that I'm going to talk about is what happens if we exclude a variable that should be included in the model. For example, if this is the true model, but we underspecify our model and estimate this model. Right, so we are omitting a variable that should be in this equation. So what happens then? This type of problem is called omitted variable bias. In that case, our beta coefficients that we will get from this model, it will not be equal to the actual beta. And remember, this is what we want. We want these two parameters to be equal. But if there is omitted variable bias, then these two coefficients are not equal. In the next video, I'll show you an example and what happens when there is an omitted variable bias, and we'll talk about that bias could inflate or deflate our estimated effects. And I'll also show you an example of omitted variable bias, but this is problematic and we have to deal with it. All right, I'll see you in the next video. Bye bye.